I am Richard Feynman, and when people talk about time, they usually imagine a single universal river flowing smoothly through the entire universe. One clock, one rhythm, one cosmic heartbeat ticking the same for everything, everywhere. That picture is comforting and completely wrong. Time is not a background that the universe sits inside. It is not a master clock hanging somewhere outside reality, ticking away impartially. Time is something far stranger, far more personal. It depends on motion. It depends on energy. It depends on the particle itself. When you look closely enough, you discover something unsettling. Time does not pass the same way for every particle. In fact, for some particles, time barely passes at all. For others, it stretches, slows, twists, and behaves in ways that completely destroy our everyday intuition. This isn't philosophy. This isn't speculation. This is a direct consequence of the laws of physics as we actually measure them. The universe does not ask for permission before violating your common sense. It simply does what the equations say, and the equations say that time is not universal. It is local, relative, and deeply tied to how matter and energy move through space. To understand why time is different for every particle, you must abandon the idea that time exists independently of motion. In classical physics, time was treated as an absolute, something that ticked along the same way, whether anything happened or not. But that picture collapsed the moment Einstein showed us that space and time are welded together into a single structure, spacetime. Once that happens, time stops being a passive observer and becomes an active participant. Every particle moves through spacetime in its own way, and the path it takes determines how much time it experiences. A particle sitting still relative to you moves entirely through time. A particle moving fast must spend some of that motion moving through space instead. The faster it moves through space, the less motion it has left for time. This is not a metaphor. This is geometry. Space-time has a fixed structure, and every particle traces out a path through it. That path, the particle's world line, determines how much time passes for that particle. Time is not something that happens to particles. Time is something particles do. Now here's the part that really disturbs people. Different particles trace different paths through space-time, even when they appear to exist in the same place at the same moment. Two particles can be side by side, created in the same event, and yet experience completely different amounts of time. Take a muon, for example, a particle created when cosmic rays strike Earth's atmosphere. According to our clocks, the muons should decay long before reaching the ground. Their lifetime is too short, and yet they reach the surface in enormous numbers. Why? Because from the muon's perspective, time is running slower. The muon is moving so fast relative to Earth that time itself stretches for it. From our point of view, the muon lives longer. From the muon's point of view, the distance to Earth is shorter. Both descriptions are correct. That is the crucial lesson. Time is not absolute, and distance is not absolute. They trade with each other depending on motion. Each particle carries its own clock, and that clock ticks according to the particle's journey through space-time, not according to some universal schedule. Now let me take you to the extreme case, because physics always reveals its secrets at the extremes. Consider light, a photon. It has no mass, and because of that, it must travel at the speed of light. It has no choice. And when you apply the equations honestly, something astonishing falls out for a photon. Time does not pass at all. From our perspective, light can take billions of years to cross the universe. But from the photon's perspective, if such a perspective can even be defined, there is no before and after. Emission and absorption happen at the same instant. Zero elapsed time. That should terrify you, because it means that time itself is not a fundamental ingredient of reality. It is not required for all physical processes. Some particles experience time. Some barely experience it. Some don't experience it at all. Time is not universal. It is conditional. It depends on mass, motion, and the geometry of space-time. The idea of a single cosmic clock shatters completely when you look at light. What this tells us is something deeply uncomfortable. Every particle carries its own version of time, not metaphorically, literally. In relativity, the proper time of a particle is the time measured along its own path through space-time. Two particles starting together and ending together can experience different amounts of time, depending on how they move in between. There is no contradiction here. The universe does not insist on fairness. It insists on consistency. Space-time geometry allows multiple clocks to tick at different rates, and all of them are correct. Time dilation is not an illusion caused by measurement error. Clocks physically run slower when they move faster or sit in stronger gravitational fields. Atomic clocks on airplanes tick differently than clocks on the ground. GPS satellites must correct for this effect, or your navigation would drift kilometers per day. These aren't philosophical curiosities. They're engineering problems solved by accepting the brutal truth. Time depends on the particle, not the universe. And now we arrive at the point where intuition completely collapses. If time depends on motion, and motion is always relative, then there is no universal, no. There is no single present moment shared by the entire universe. What is no? For one particle is not no for another moving differently. Events that appear simultaneous to you are not simultaneous to someone moving relative to you. This isn't perception. This is reality. Space-time does not slice itself into neat, universal moments. Each particle carries its own slicing. Each world line defines its own sequence of events. The universe is not evolving frame by frame like a movie. All events exist within space-time, and time passing is simply how conscious systems experience their own world lines. Physics does not privilege your experience of time over that of a particle, a satellite, or a muon screaming through the atmosphere. The equations treat them all equally, and that equality destroys the idea of a single, shared temporal flow. At this stage, people usually ask me, if time doesn't flow, why does it feel like it does? That question finally brings us to entropy. The so-called arrow of time does not come from the laws of physics themselves. Almost all fundamental equations work perfectly well forward and backward in time. They don't care which direction you run them. What breaks the symmetry is statistics. Entropy measures how many microscopic arrangements correspond to the same macroscopic situation. Systems naturally move from unlikely, ordered states to likely, disordered ones, not because they must, but because there are overwhelmingly more ways to be disordered. Particles don't know about past or future. They simply move according to local rules. But when you have trillions upon trillions of them interacting, patterns emerge. Those patterns create what we experience as irreversibility. The arrow of time is not built into particles. It is built into large collections of particles. That's why time has a direction for you, but not for an electron. This distinction is critical. A single particle does not remember. It does not record history. It does not anticipate outcomes. Memory itself is a physical process, one that requires irreversible changes in matter. Your brain works because it constantly increases entropy, dissipating energy, locking information into physical states. That process gives you a past and a future. A particle has none of that. It simply exists at events along its world line. Asking a particle, "What time is it?" makes no sense. Time is not something it experiences internally. Time is something we assign when we describe its motion relative to other systems. When we say time is different for every particle, what we really mean is that every particle participates in space-time differently, and only complex systems translate that participation into the feeling of temporal flow. Time belongs to thermodynamics and information, not to fundamental particles. This is why physics forces us to separate two ideas, that people constantly confuse time as a coordinate and time as an experience. In the equations, time is just one dimension among others, treated mathematically, coldly, without emotion. In your life, time feels urgent, directional, unstoppable. But that feeling is not written into space-time. It emerges from the way your brain processes change. Particles don't age. They don't wait. They don't rush. They don't feel duration. They simply connect events according to the geometry of space-time. Once you understand this, you stop asking when time flows and start asking why complex systems, like humans, experience it at all. And that question no longer belongs purely to physics. It spills into biology, information theory, and consciousness itself. Let's push the equations to their breaking point, the speed of light. As a particle approaches light speed, something extraordinary happens. Time stretches without bound. The faster the particle moves, the less time it experiences. This is not because time slows down in some mechanical sense, but because space-time geometry reallocates motion. Motion through space steals from motion through time. At the limit, for a massless particle like a photon, there is no time left at all. This tells us something profound. Time is not a substance that flows uniformly. It is a measure of how a world line cuts through space-time. Near light speed, that cut becomes almost entirely spatial. The particle still participates in events, but the interval we call time collapses. This is why no massive particle can reach light speed. Doing so would require eliminating its own passage through time, which would require infinite energy. The universe enforces its geometry with absolute consistency. Let's push the equations to their breaking point, the speed of light. As a particle approaches light speed, something extraordinary happens. Time stretches without bound. The faster the particle moves, the less time it experiences. This is not because time slows down in some mechanical sense, but because space-time geometry reallocates motion. The motion through space steals from motion through time. At the limit, for a massless particle like a photon, there is no time left at all. This tells us something profound. Time is not a substance that flows uniformly. It is a measure of how a world line cuts through space-time. Near light speed, that cut becomes almost entirely spatial. The particle still participates in events, but the interval we call time collapses. This is why no massive particle can reach light speed. Doing so would require eliminating its own passage through time, which would require infinite energy. The universe enforces its geometry with absolute consistency. Now consider simultaneity, the idea that two events happen at the same time. In everyday life, this seems obvious. In physics, it evaporates. Two observers moving relative to one another will disagree on which events are simultaneous. Neither is wrong. Each uses a valid slicing of spacetime. This means there is no global present shared by all particles. When you say, now, you are choosing a particular frame of reference, one among infinitely many. A particle moving differently chooses a different slicing, a different ordering of events. The universe does not privilege your choice. It does not synchronize itself to your clock. Each particle's history, its ordering of events, is defined along its own world line. This is why asking for a universal time is like asking for a universal direction in space. It doesn't exist. Direction depends on orientation. Time ordering depends on motion. Once you accept this, the idea of a single, objective, no, collapses completely. There is no cosmic moment sweeping across the universe, updating reality everywhere at once. Events don't wait for each other. They simply exist at locations in space-time, connected by causal structure. What you call the present is a thin slice your brain constructs to make sense of change. It's a convenience, not a feature of the universe. Particles do not line up and agree on a shared moment. Each follows its own path, carrying its own proper time, defining its own sequence of events. When we say time is different for every particle, we are stating a hard fact: the universe does not come with a built-in clock. Time is not something the universe keeps. It is something observers infer. At this point, people usually panic and ask, if there is no universal time, does cause and effect fall apart? The answer is no. And this is one of the most beautiful things physics ever discovered. Causality does not depend on a universal clock. It depends on light cones. In space-time, each event divides the universe into three regions: events that can affect it, events it can affect, and events that are completely disconnected. No matter how different particles experience time, no signal can travel faster than light. That single rule preserves cause and effect. Particles may disagree about the order of distant events, but they will never disagree about whether one event can influence another. Time ordering is flexible. Causality is not. This is why physics remains consistent, even when time becomes personal. The universe allows many clocks, but it enforces one causal structure. This brings us to something even more fundamental than time: information. What truly limits physics is not how fast time flows, but how fast information can move. The speed of light is not just a speed. It is the maximum rate at which cause can propagate. Particles don't carry time forward. They carry information through space-time. When we describe time dilation, what we are really describing is how information processing systems behave under motion and energy. Clocks are information machines. The memory is stored information. Entropy is information spread out and lost to microscopic degrees of freedom. Once you see this, time begins to look less like a river and more like an accounting system. A way to track correlations between events. Each particle participates in this accounting differently, depending on its motion and energy. So when we say earlier and later, we are not invoking absolute categories. We are describing local relationships. Earlier than what? Later than whom? A particle defines its own ordering along its world line. Outside that path, the ordering of events can change depending on perspective. This doesn't weaken physics. It strengthens it. It tells us the universe is built from relationships, not from absolute labels. Time is one of those labels we invented because it works so well for creatures like us, living slowly, moving weakly, and made of enormous numbers of particles. But strip reality down to its foundations, and time loses its authority. It becomes contextual, flexible, and deeply personal to each particle. Here is the final, uncomfortable truth. Particles do not experience time at all. Experience requires memory. Memory requires irreversible physical change. Irreversibility requires entropy. A single particle has none of these. It does not remember where it has been. It does not anticipate where it is going. It simply participates in events. When physicists talk about a particle's proper time, we are not describing an inner experience. We are describing a geometric quantity, the length of its path through space-time. That number exists whether or not anyone measures it, but it is not felt. Feeling time is something complex systems do. Brains do it. Clocks do it. Thermodynamic systems do it. Particles do not. So when you ask why time is different for every particle, the deeper answer is this: time is not something particles possess. Time is something we assign when we describe their relationships. The universe runs perfectly well without any awareness of past or future. And this is where everything comes together. Humans experience time because we are not fundamental. We are built from astronomical numbers of particles interacting, recording information, dissipating energy, and increasing entropy. That process creates memory, direction, and the sensation of flow. Time feels real to us because our biology depends on it. But physics does not. At the deepest level, the universe is not evolving moment by moment. It is a space-time structure where events simply exist, connected by causal rules. Each particle traces its own path. Each path has its own measure of time. There is no universal clock, no cosmic now, no single rhythm beating behind reality. Time is different for every particle because time is not a thing the universe hands out equally. It is a consequence of motion, energy, and perspective. Once you understand that, you stop asking where time goes and start asking why we feel it at all. That question doesn't weaken physics. It reveals how astonishingly subtle reality really is.